Hello, in this video I'll be going over number 1, which deals with the transfer function with hs and finding the impulse response function ht. So for this problem we need to remember this equation. Right here I wrote in green, hs equals ys over g of s, and this pretty much just means that in order to solve for h of s, we're going to need to take the Laplace of our equation down here below. So I'll take the Laplace to the left side and the right side. And since our y of 0 and our y prime of 0 are both equal to 0, we don't have to worry about the other terms that comes with taking the Laplace of y, double prime, prime, and y. We can just take the term that is just the capital Y. So for the first term, we'll just get s squared capital Y plus 3 of s capital Y plus 2 capital Y equals G. And if you want, you can put of s with a parentheses if you want. I just don't like to put it down just because it's extra writing. So now the next step, since I want to have y of s over g of s, I need to get it into a form where I can just manipulate y of s as a singular term and not multiples. So that means I'm going to have to take out the y from each of these terms. So it's going to become capital Y times s squared plus 3s plus 2 equals g. So I'm going to get y over g, so I'm going to divide the g over and then the s squared terms over. So now I have 1 over s squared plus 3s plus 2 equals y over g. So now that I have y over g, I know that this equals h of s. I'm going to go ahead and rewrite that to make it a little easier to look at. So h of s would then equal 1 over s squared plus 3s plus 2. But now we found our h of s term. Now we need to find our h of t term, which is going to be doing the inverse Laplace of h of s. So we need to get this right side over here into a form that we can take the inverse Laplace of. Right now, this is where the denominator is there's nothing that matches up with anything in our Laplace table. So what we're going to have to do is do partial fractions by factoring the denominator and splitting it up into two separate terms. So h of s would equal, well, I'll factor it first and then I'll show those terms. So s squared plus 3s plus 2, you do s plus 2 and s plus 1. Think about it, that makes sense. Multiply 2 and 1 to get 2, and then add up 2s and 1s to get 3s, and then s squared to get s squared, or s times s to get s squared. And now we can equate this to a over s plus 2 plus b over s plus 1. And it doesn't really matter which one you choose, just make sure you keep track of what number goes with your s plus 2 and your s plus 1. Doesn't matter if you have a or b to it, it's the number that matters. So we need to solve for a and b using partial fraction. So I would just go ahead and use, I forgot what it was called, Heaviside method. So the way Heaviside works is that we're going to take the limit as s approaches, and we're going to choose either a or b. So I'm going to choose a, so that means we're going to solve for s whenever it equals, or s plus 2, or solve for s whenever that term equals 0. So that implies s equals -2, so where s is going to approach -2 of 1 over s plus 2, s plus 1. I'll multiply this by s plus 2. And it is going to equate to this side over here, a over s plus 2 plus b over s plus 1. And I'll multiply this entire side as well by s plus 2. And when I do that, it will cancel out with this term with a, but it won't cancel out with b. So I'll rewrite this as a times s plus 2 or sorry, a plus b times s plus 2 over s plus 1. And I need to make sure I keep track of my limit as well. So this would mean that this term right here goes to 0, because as s approaches -2, this s plus 2 term will go to 0, and this s plus 2 cancels out with this. So this implies a equals the limit as h approaches -2 of 1 over s plus 1, which would then equal 1 over -1, which is just -1. Now we can do the same thing for b, and I've already kind of I did all the work for this first one just to help you understand heavy side a little bit better. But I'm just going to say b equals the limit, and same thing we did before with s plus 2, s plus 1 equals 0, which implies s equals -1. So the limit would be s approaches -1, and we're going to multiply by s plus 1 term to our left side that we have over here. So that means we're going to do the limit as s approaches -1 of s plus 2. And the reason why we're getting b is because when we multiply s plus 1 to our right side over here, it'll make the a term go to 0, since the s plus 1 term cancels out with the denominator for b. So then all I have to do is plug in -1, and it should equal 1. Because I'll have 1 plus 2, 1 over -1 plus 2. So now that I have my a and b, this implies h of t equals the inverse Laplace of h of s, which equals the inverse Laplace of -1 over s plus 2 plus 1 over s plus 1. And that right there will equal negative e to the negative 2t plus e to the negative t. And remember, our coefficients for our t's is based off of this Laplace transform, s of 1 over s plus a will equal e to the a t, negative at. So final answer right here for h of s, sorry, h of t, and final answer for h of s right here. So if you have any questions, please let me know in the comments or email me.